There's a patient lying on an operating table in Washington, D.C. right now, chest open, waiting for a heart. But where's the heart? Well, that heart is here, at JFK International Airport in New York, inside what looks like the cooler you bring to a barbecue. This heart has been outside a human body for almost 2 hours, and it has exactly another 2 hours left before it becomes biological waste. And the journey from JFK to the hospital in DC alone is an hour and a half long. So yeah, the math doesn't work, which is a problem because someone's life depends on it. But before we get to how they would pull that off, we need to see how a human heart ended up in a cooler at JFK in the first place. This story starts in the ICU. When a patient has a catastrophic brain injury and doctors know there's no coming back, they're legally required to make a phone call, not to the morgue nor the family, but to an OPO, an organ procurement organization. There are 56 of these in the US alone, and their entire job is to make sure that if you're going to die, your organs don't just go down with the ship. Whenever a doctor declares a death, a coordinator from the OPO drives to the hospital, reviews the patient and their medical history, and sees which organs are healthy enough to save someone else's life. They also check whether the patient has previously registered as a donor. If everything checks, they start to proceed and the clock starts. Now, most people picture organ donation like this. Surgeon removes the heart, puts it in a container, finds the nearest match, and the helicopter goes brrr. But this isn't how it works. The organ doesn't go to the person who's been waiting the longest or the person with the biggest bank account. The organ goes to whoever lands at the top of a computer-generated list, which is recalculated in real time based on blood type, tissue match, body size, medical urgency, and a whole lot of other factors. In the US, that list is managed by UNOS, United Network for Organ Sharing. In Belgium, where I live, and most of Europe, it's Transplant, one network that covers 8 countries at once. The whole point of all of this is to get the right organ to the right person before biology wins, and the window to do that is terrifyingly short. There's also a villain in this story, which, in our case, is time. The moment an organ leaves a human body, it starts dying. For the heart and lungs, you have about 4 to 6 hours, which, for context, is roughly the same amount of time it takes to watch The Irishman, except if you're late, someone actually dies. The liver survives up to 8 to 12 hours. Kidneys up to 36 hours, which sounds generous, until you're trying to fly something across multiple countries. This is called cold ischemia time. The organ is kept cold and without blood flow, and every extra hour in that window increases the odds that the organ won't work after transplant. And here's where it gets really complicated. The donor and recipient are almost never in the same city, sometimes not even in the same country. So the moment a heart is approved, someone has to figure out how to move it safely, quickly, and without it dying in transit to a patient who might be 1,000 miles away. And doing this wouldn't be possible if we didn't get the next part right, which is packaging. You don't just chuck a heart in a Ziploc bag. There's a very specific protocol for this. First, a special surgical team from the OPO removes the organ and then flushes that organ with a special ice-cold preservation solution. It does 3 things at once. It washes out the donor's blood to prevent clotting. It chills the organ down to around 4 degrees Celsius to slow its metabolism, and it delivers chemical nutrients to keep the cells alive. Then comes the triple layer protocol. The organ goes into a sterile bag filled with preservation fluid. That bag goes inside a second bag. Those 2 go inside a third bag. Then, the whole thing goes into a hard, insulated cooler, packed with ice slush. The organ can never actually touch the ice. Direct contact freezes the tissue, which is just as damaging as letting it get too warm. So the slush has to surround it without touching it. Once packed, it gets a label called ISBT 128, a 13-character ID unique in the entire world. It has blood type, organ type, origin, and recovery time all encoded, because misidentifying an organ isn't like a paperwork error. It could cost someone their life. While the organ is being packed, the algorithm is already running. The donor's data, their blood type, tissue type, body size, and location gets entered into the national database, and what comes out is called a match run, which is a ranked list of potential recipients. For a liver, doctors use a MELD score, a number from 6 to 40. The higher your score, the closer you are to dying, and the higher you rank on the list. For kidneys in Europe, Eurotransplant awards points for things like wait time, tissue match quality, age, and urgency. Once the list is generated, the OPO starts calling down it. Each doctor gets exactly 60 minutes to review the donor's file and say yes or no to the organ. If they refuse, then the organ is offered to the next name on the list. Okay, now the organ is packed, recipient is confirmed, now it has to get there. Which brings us back to the heart, which is already sitting at JFK. For a heart, there's no time for anything slow. You need a private jet or a helicopter. And these flights get priority routing from air traffic control, meaning they can take the most direct path possible and land ahead of other planes. Now, kidneys, being the most resilient, can actually travel on regular commercial flights. The FAA, Federal Aviation Administration, has specific rules letting these packages bypass cargo restrictions and ride in the passenger cabin. So yes, there is almost certainly an organ on your flight right now. The whole time, a GPS tracker on the cooler is sending live location and temperature data back to the OPO. If the box gets too warm or if the flight is delayed, they know instantly. Now, for most of transplant history, keeping an organ alive meant one thing: pack it cold, move it fast, hope it holds. But in the last decade, something called machine perfusion changed that completely. Instead of just keeping the organ cold and still, you hook it up to a machine that acts as a surrogate body, pumping preservation fluid or oxygenated blood directly through the organ the entire time it's in transit. But the actual game-changing part is this: doctors can test the organ mid-transport. They can check how well it's functioning before committing to the surgery, which means organs from older or less than perfect donors, ones that would have been thrown away under the old system, can now be evaluated and used, which means more viable organs, more lives saved. It's one of the biggest shifts in transplant medicine in a generation, and most people have never heard of it. So, back to the operating room. The courier arrives. A staff member checks the ISBT 128 barcode against the recipient's file. After verifying, the organ goes straight to the operating room, where the recipient is already under anesthesia. The surgeon opens the 3 bags, does a final check, and begins. And the moment the last blood vessel is connected, the moment blood starts flowing again, the organ turns pink. That's when you know it worked. For a heart, that entire chain, donor to recipient, cooler to chest, has to happen in under 4 hours. 4 hours. For something that involves complex technology, logistics, and hundreds of individual decisions made in real time. The system isn't perfect. Flights still get delayed. Matches fall through. Not every organ makes it. But somehow, hundreds of thousands of people get a transplant every single year. If this kind of behind-the-scenes logistics stuff is your thing, you'll probably enjoy the last video I made about the insane iceberg project, which should be appearing in front of you. Go watch it.